In this video, we're going to look at how to solve for the coefficient of kinetic friction for a mass sliding down an inclined plane at constant velocity. The problem reads a 4.00 kilogram mass is placed on an inclined plane that makes an angle of 30 degrees and slides down at constant velocity. Find the coefficient of kinetic friction. So the first thing that we want to do is we want to draw a picture of what's going on, and we want to put our forces on that picture so that we have a free body diagram and we can visualize everything. So here's my inclined plane. My angle of the incline is 30 degrees. And now when I draw my mass, since we are on the Earth, I'm going to have a force due to gravity and it's going to point directly towards the Earth. In this problem, we're told we're looking for the coefficient of kinetic friction, so we know that there must be friction. Additionally, since we know it's sliding down the incline, we know friction opposes motion, and friction must be pointing up the incline. And then because we are on a surface, we have a normal force, and the normal force is always going to point directly out of the surface. Now we're going to choose our axes to be parallel for our x-axis and perpendicular for our y-axis, and that's parallel to this plane and perpendicular to this plane. So over here I'm just going to redraw the axes, but I'm going to place them directly up and down, so it's as if I've rotated it and it's easy to look at. So now I have a normal force which lies directly on my y-axis, a force of friction which lies directly on my x-axis, and then what I have is I have two components of my weight, or my force due to gravity. There's another video where we talk about breaking up this Fg into the two components that lie on the axes, so if you're not sure how to do that, you should go watch that video. And once we break everything up, it's really simple because everything that lies on an x-axis we can add together, and everything that lies on a y-axis we can add together. Now we recall that the weight Fg, the force due to gravity, is equal to mass times the acceleration due to gravity. In the x direction, it turns out that this x component is going to be mg sine theta, theta being this angle right here, and in the y direction it's going to be mg cosine of theta. So this is how we are going to resolve the x or parallel component and the y or perpendicular component. In the problem, we're told that we have a 4 kilogram mass, and we're told that the angle is 30 degrees, and as always we're going to use a value for the acceleration due to gravity of 9.81 meters per second squared. Right now I'm not really concerned with direction, because after I find my FGX and my FGY, then I'll go ahead and decide if I want to make this my positive Y or this my positive X. So I plug in my mass, my acceleration due to gravity, and my angle, and I'll find in the X direction 19.6 newtons, and in my Y direction 34 newtons. In other words, this weight component right here, this full weight, it turns out, can be thought of as having an X component of 19.6 newtons, which is what causes the mass to slide down the plane. So this X component is the one pulling the mass down the plane, and this Y component is the one pulling the mass into the plane. So now I want to break up my problem into an X and a Y direction. As always, I'm going to take my net force, I'm going to look at my free body diagram, and as the net force means all of the forces, I'm going to look at all of the forces in my X direction, which are Fgx and the force of friction. I know my Fnet is 0 newtons. I know that because it says constant velocity, so I have no acceleration. I've decided to make this my negative axis, so Fgx is going to be negative. And that means since we're at constant velocity, the force of friction must exactly balance it out. So my force of friction is a positive 19.6 newtons, meaning to the right. In other words, Fgx made the mass want to slide down the plane, and I called down the plane negative. And the force of friction wanted it to stay where it was, so it pointed up the plane, and I made up positive. On the y side, I am not accelerating into or out of, I'm not bouncing up and down at all. So in my y direction, it turns out that F net is also going to be 0. And all of the forces are the y component of gravity and the normal force. I already found my y component of gravity, which right now I've decided to call positive. So I decided to call down positive on this axis. I'm going to find that my normal force is 34 newtons, but it's negative, meaning it points up. Now, I'm looking for a coefficient. I'm going to recall that mu, the coefficient of friction, is the force of friction divided by the normal force. And if I plug it into this equation and I plug in my two forces, I would find that my mu is negative, right? A positive divided by a negative is negative. And what's really important here is to remember that this equation cannot tell us the direction that friction is going to act or that the normal force is acting. All it can do is it can relate magnitudes. Because what if we were pushing the block up the plane? What if we applied a force to push the block up the plane? Well, the coefficient of friction wouldn't change, but the direction of our force of friction would, because if we were pushing the block up the plane, the force of friction would try to stop that motion and it would point down, so our sign would change. So I plug this in a calculator, and what I'm going to find is negative 0.576 is my coefficient, and like we just talked about, what I need to do is I need to take the absolute values, because this equation only relates magnitudes or absolute values, so I'm just going to change that to a positive, and now I found that my coefficient of kinetic friction is 0.576 between whatever this mass is and that plane.